Hello everyone, today we will start chapter 6 of mass transfer operations, which talks about humidification and drying. So what is meant by humidification? Humidification is the process of adding moist into the air. However, drying is the removal of moisture from solids. So this is the main difference between them. So humidification is occurring because of the contact of liquid water with the dry air, which will cause evaporation of some of the liquid into the air. So this is what is meant by humidification, is the contact of liquid water with dry air, which will result in evaporation of some of the water into the air, which is called humidification. And dehumidification is the opposite of humidification, is contact of very moist air with pure liquid water, which will result in condensation. So some of the moist will condense, the liquid droplets will fall down. So this is what is meant by dehumidification. And in the both cases, it happens because of the diffusion of water vapor through air. And the driving force is concentration. It goes from high concentration area to low concentration. What is meant by absolute humidity? Absolute humidity is the mass of water vapor per mass of dry air. Absolute humidity measures mass of water vapor present per mass of dry air, and it tells us how much moisture exists in the air. That's why it is called absolute humidity. And molal humidity is the same concept, but we're dealing in molal absolute humidity with moles. That's the main difference between them. So moles of water vapor over the moles of dry air. So this is molal absolute humidity. And saturated air, what is the difference between saturated air and saturation humidity and percentage humidity and relative humidity? There are differences between them. So saturated air becomes saturated when it cannot hold more water vapor at that temperature. So this is what is meant by saturated air. And at this point, the partial pressure of water vapor will be equal to the vapor pressure of pure water. And saturation humidity is the humidity of saturated air. So saturated air and saturation humidity are relative to each other, are related to each other. Saturated air is when the air cannot hold more water vapor at that temperature. And the saturation humidity is the humidity of this saturated air. Percentage humidity compares actual humidity to saturation humidity. So it is the ratio of absolute humidity to saturation humidity multiplied by 100. That's why it is percentage. Then relative humidity or relative saturation, they are the same thing. Relative humidity is the ratio of the partial pressure of water vapor in the air-water vapor system to the vapor pressure of pure water at dry bulb temperature of gas mixture. And we will go through dry bulb temperature, wet bulb temperature, and dew point. So dew point is the point when, first I will talk about dry bulb temperature. Dry bulb temperature is the temperature measured using normal thermometer, and the bulb of this thermometer should be dry. That's why it is called dry bulb temperature. And wet bulb temperature is measured using a thermometer covered with a wet cloth. That's why it is called wet bulb temperature. This is the main difference between them. So we talked about dry bulb temperature, wet bulb temperature. Dew point is the temperature where moist air becomes saturated and condensation begins. Dew point, نقطة الندى. when the temperature at which a vapor gas mixture becomes saturated and condensation occurs or begins. If air cools below dew point, water droplets form. We're having like dew, fog, and other things. Dry bulb temperature is the temperature of a vapor gas mixture as ordinarily determined by immersion of a thermometer in the mixture. Wet bulb temperature. A thermometer, the temperature of a thermometer whose bulb has been covered with a wet wick, is immersed in a rapidly moving stream of the gas mixture. The thermometer will indicate the temperature lower than dry bulb temperature. Why is that? The thermometer here in wet bulb temperature is having a lower temperature than dry bulb temperature, because a wet bulb temperature we will be having a bulb which is covered by a wet cloth, so the temperature will be lower because the wet cloth will cool down this thermometer. So when we are cooling things, we're decreasing their temperature. That's why it is lower than dry bulb temperature. Humid heat and humid volume. Humid heat is basically like heat capacity. It is the amount of heat required raising the temperature of 1 kilogram of dry air and water vapor present in it through 1 degree centigrade or 1 Kelvin. So this is what is meant by humid heat. Is the heat the amount of heat required to raise one temperature of 1 kilogram of dry air by 1 degree Celsius or 1 Kelvin. That's it. Humid volume is the total volume occupied by 1 kilogram of dry air plus the vapor it contains at absolute pressure, and the given temperature is called humid volume. So humid volume is the temperature when, it is the temperature at absolute pressure when the total volume occupied by 1 kilogram of dry air plus the vapor it contains. Cooling tower. So this slide introduces main parts, like we're having frame and casing, fill basin, fans, nozzles, drift eliminators, air inlet. Cooling towers remove heat from hot water, and they are widely used in power plants, industries, and air conditioning systems. So their principle, or the cooling tower principle, is some water evaporates into moving air, and this evaporation removes heat, causing remaining water to cool down. That's the main principle of cooling tower. The role of cooling tower is to remove heat from hot air, and its principle: some water evaporates into moving air, and this evaporation removes heat, causing remaining water to cool down. And this makes cooling towers energy efficient and economical, because we will consume energy and electricity and other things, so it will be energy intensive. This is the schematic diagram of a cooling water system. So first, warm water will be introduced from the top of the tower. Then this warm water will be sprayed downward, and the air will comes from the bottom of the tower. So the air is coming, and the hot water or the warm water will be sprayed. So the contact, there will be a contact between air and water, which will cause water to evaporate, and this evaporation takes away heat. So air is blown upward through the tower. As air contacts the falling water, water evaporates and takes away heat from the water. Therefore, the water leaving the tower becomes cooler. That's it. This is the principle of cooling tower from the diagram. The components, as we said, frame. Most towers have structural frames that support the exterior enclosures, casings, motors, fans, and other components, with some smaller designs such as some glass fiber units. The casing may essentially be the frame. Frame and casing provide structural support. It is the foundation of this cooling tower. It is like the main thing. So it provides structural support for fans, motors, and tower walls. Then fill. The main role of fill is to increase contact area between air and water, because if we're having high contact between air and water, the cooling process will happen efficiently. And we're having two types of fill. We're having splash fill as well as film fill. Splash fill is related to dirty air, and film fill is used for clean air. So splash fill, water breaks into droplets while falling over bars. So water falls over successive layers of horizontal splash bars, as well as splash fill is horizontal, but film fill is vertical. So water falls over successive layers of horizontal splash bars, continuously breaking into smaller droplets while also wetting the fill surface. Plastic splash fills promote better heat transfer than wood splash fills. So plastic splash fills is better than wood splash fills when we're talking about heat transfer. So it will be better. It promotes better heat transfer, plastic splash fills, than wood. Film fill consists of a thin, closely spaced plastic surfaces over which the water spreads, forming a thin film in contact with the air. From its name, it is film fill. It has a thin film. So film fill, water spreads as thin films over surfaces. And film fill is more efficient as it requires less space. Cold water basin is located at the bottom of the tower. This is the cold water basin. So its function to collect the cold water. This water is then pumped back into industrial systems. That's why we're having then pump. Also we want pump to increase the efficiency because it will go again to the cooling tower. Okay, so cold water basin, its function is to collect cold water, and this water is then pumped back into industrial systems. Then drift eliminators, these capture water droplets entrapped in the airstream that otherwise would be lost in the atmosphere. So drift eliminators are used to eliminate or prevent water droplets from escaping with air, and this reduces water loss and it decreases environmental problems. Air inlet allows fresh air to enter tower, and louvers, they help distribute airflow evenly and they help to prevent water splashing outside. This is the main roles of louvers. Nozzles, they are used to spray water to wet the fill, and also they are used to help uniform spraying or to maintain uniform spraying. Fans move air through tower. We know what is the role of fans. Move air through tower, and we're having two types of fans: axial fans and centrifugal fans. And the fans, they are helpful in air circulation and heat transfer. There are two types of cooling towers. We're having natural draft cooling tower or hyperbolic cooling tower, as well as mechanical draft cooling tower. So first, with the natural draft cooling tower, which depends on the natural convection, and it's also called hyperbolic cooling tower because of its hyperbolic shape, which gives the structure strength, and it improves the natural airflow. So natural draft cooling tower works using natural convection. Hot rises upward naturally, drawing cool air inside, and it has two advantages: that there is no fan required because it depends on the natural convection, and it has low operating cost. However, it has two main disadvantages, which are very expensive in construction and it requires a very large area. And these kind of cooling towers mainly used in power stations, and this is about natural draft cooling tower. With the mechanical draft, we are using mechanical devices like fans, pumps, and other mechanical devices. So here we use mainly fans to move the air. So fans either push the air or pull air. So the advantages of mechanical draft cooling tower, that it is more compact, better control, and higher cooling efficiency. However, it has two disadvantages, like requires electrical power and higher maintenance. And in natural draft cooling tower, we're having two types: cross flow tower and counter flow tower. So here everything we said, the natural draft or hyperbolic cooling tower makes use of the difference in temperature between the air as hot air moves upward through the tower, because hot air rises due to the layout of the no fan required. There are two main types of natural draft towers: cross flow tower and counter flow tower. Cross flow tower, air is drawn across the falling water and the fill is located outside the tower. But in counter flow tower, air is drawn up through the falling water and the fill is therefore located inside the tower, although design depends on specific site conditions. So here the fill is located outside the tower in cross flow tower, but in counter flow tower it is located inside the tower, the fill, and the design depends on specific site conditions. This is the natural cooling tower diagram. Mechanical draft cooling tower, they are having big fans to force or draw air through circulated water, either by pulling the air or pushing the air. The water falls downward over fill surfaces, which help increase the contact time between the water and the air. This helps maximize heat transfer between the two. Cooling rates of mechanical draft towers depend upon various parameters such as fan diameter and speed of operation. Fills for system resistance. Mechanical draft cooling tower. Here there is a centrifugal fan which will blow the air upward, and the hot water will be introduced from the top of the tower. So then it will fall down and sprayed because of these sprayers. Then there will be a contact between the water and the air, which will cool the water, and the water will be collected from the bottom of the tower. Performance of cooling tower. Range is the difference between the cooling tower water inlet and outlet temperature. So this is the difference between the two temperatures, the inlet temperature and the outlet temperature. A high CT range means that the cooling tower has been able to reduce the water temperature effectively and is thus performing well. The formula is inlet temperature minus outlet temperature. And the approach is the difference between the cooling tower outlet cold water temperature and ambient wet bulb temperature. The lower the approach, the better the cooling tower performance. Then with the effectiveness and cooling capacity. Effectiveness measures tower's efficiency, and higher the efficiency, the better the tower operation. Cooling capacity is related to heat removed by tower. It is the heat removed by tower, and it depends upon three things: water flow rate, specific heat, and temperature drop. And the effectiveness is 100 multiplied by the range over range plus the approach. The cooling water inlet minus the cooling water outlet over the cooling water inlet minus the wet bulb temperature. Drying equipment is used to remove moisture from materials or solids, as we said, by using hot air or gas. So we're having two common dryers, which are tray dryers and spray dryers. So first with the tray dryer. Tray dryer is the simplest type of a batch dryer. Also it is called cabinet dryer or compartment dryer. Batch dryer means material is loaded once, dried completely, then removed before adding a new batch. So it works by passing hot air over wet material placed on trays. And its construction, it consists of insulated cabinet, trays, racks or trucks, air inlet and outlet, heating coil, and fan. So first with the insulated cabinet, which is a closed chamber or cabinet. It is insulated to reduce heat loss. Then we're having trays or plates. They are plates. So wet material is spread on removable trays. Trays may be solid metal sheets or wire screen. So it can be made of sheets or from screens. And as we said, trays are stacked or loaded on trucks. Then we're having air inlet and outlet to allow hot air to enter and moist air to leave. Heating coil heats the air. In these dryers, steam, gas, or electrically heated air is used as a drying medium. The air is circulated in the dryer over the trays by means of fan fitted at the top or at the side. So also we have fans to circulate hot air over the trays, and usually fans are fitted at the top or at the side of the dryer. Then how tray dryers works: first we will spread the wet material uniformly on trays. Then trays are placed inside the cabinet. Cabinet is closed. Then with the heating process, steam or electricity heats the coils. So here, steam or electricity heats the coils, so the air becomes hot. Then with the drying, fans circulates hot air, as we said, over the wet material. So hot air absorbs all the moisture from the material. Then the air circulation is about 80 to 95% of air is recirculated using a damper. Then this saves heat and energy. Remaining moist air is exhausted outside from the outlet. Then after drying, the cabinet is opened, dry material is removed, and fresh wet material is loaded. So it works as a batch-wise. Trays are usually made up of stainless steel or enameled iron and are fabricated from sheets of 3 mm to 6 mm thick. The advantages of tray dryers: first, it is cheap and simple, so it is easy to build and operate, and it requires a small area or space. Then it is easy to clean, low maintenance required because of few moving parts, so it requires low maintenance. Then no product loss in the tray dryers. And the disadvantages are it requires high labor and long drying time, because it can take about 4 to 48 hours per batch, so it can take 2 days, which is so long. Then it has small capacity because it hold only small quantities. Then the applications of tray dryers, it is used for pharmaceuticals, dyes, wet lumpy solids, wet filter cakes. Then with the spray dryer is a continuous direct contact dryer. Liquid feed is converted into very fine droplets, and these droplets contact hot air, so the moisture evaporates rapidly. Then the dry powder is produced, because we will feed slurries or solutions or pastes, so the product will be fine powder. So the main principle of spray dryer is that the liquid is broken into tiny droplets, and these tiny droplets have very large surface area, therefore moisture evaporates very quickly, and this gives rapid and efficient drying. So it is more efficient than tray dryer, but it is used only for slurries and pastes, so it is faster than tray dryer. And its construction, it consists of drying chamber, heater, fan, atomizer, cyclone separators, pneumatic conveying ducts. So the atomizer breaks liquid into tiny droplets, and we're having 3 common types: pressure nozzle, 2 fluid nozzle, and rotating discs atomizer. So this is the schematic diagram of spray dryer. We having the feed is pumped, then it goes to the heater, then to the chamber, and there is an atomizer. The feed is pumped to the top of the drying chamber, where it is disintegrated into small droplets by an atomizer. The large quantity of fresh air is taken in by a fan. It is heated in the heater and finally fed below the atomizer in the drying chamber. As the surface area of drops is very large, the liquid portion of these drops rapidly evaporates, and before they touch the bottom of drying chamber, they are completely dry. This dried product is taken out and conveyed to the cyclone dust collector by a stream of air. The major portion of the air is taken out through the air outlet duct, which mostly contains dust, and is sent to the cyclone. So first it is sent to the dust collector, cyclone dust collector, from the atomizer. Then it is sent to the cyclone number 1. So basically how it works, we said that the feed will be fed or pumped to the top of the chamber, then atomization will happen. Atomizer converts liquid into tiny droplets, then hot air will be subjected to it, and rapid drying will occur. Then the collection of the product will occur at the bottom of the chamber, and exhaust air will be removed through the outlet. And we're having almost 4 advantages of spray dryer. It is very fast drying because it occurs in seconds, and it is continuous operation, so it is suitable for large scale production, produces fine products, powder, and it is suitable for heat sensitive materials. And the disadvantages are it is expensive because it has a lot of equipment, then it requires a very large space or area, and it consumes energy. So as we said, it is a very fast drying, short drying times, capacity to handle heat sensitive products, control of particle size, and rapid dehydration.